In this video, we're going to look at combinations. We're going to look and compare combinations and permutations and figure out which situation requires which one. And the big thing to remember about that is that if we have a situation where the order matters, it's a permutation. If we have a situation where order does not matter, that's a combination. So we're going to look at some situations and figure out which one would be a permutation, which would be a combination. Then we're going to also actually calculate some combinations. So let's get started. First one, we're going to look through these. All we're going to do is determine whether it's representing a permutation or combination. We're going to justify our answer. I'm going to do that verbally. If you were asked to do that on a test, I would need to see your explanation clearly written out. I'm not asking you to solve. I just need to see whether or not you know whether it's a permutation or a combination. So the first one is, a medical researcher needs 6 people to test the effectiveness of an experimental drug. If 13 people have volunteered for the test, in how many ways can 6 people be selected? So it doesn't matter which of these 6 people are picked. It's not like there's a spot 1, spot 2, spot 3, and each spot is different. And so because the order does not matter, this is an example of a combination. Order does not matter. Let's look at example 3. 60 people purchase raffle tickets. 3 winning tickets are selected at random. If the first prize is $1,500, the second prize is $1,000, and the third prize is $500, in how many different ways can the prizes be awarded? This would be an example of a permutation because it matters which order you get called. So this is a permutation. The order matters. And again, we're doing 60 permute 3. Up here in that first one, we were doing 13 choose 6. Okay, number 4. How many different 5-letter passwords can be formed with the letters A, B, C, D, E, F, G, H, and H if no repetition of letters is allowed? So this is an example of the order matters. Okay, so because once you pick a letter, you can't repeat it, and the first letter is different than the second letter, and the order matters if you type it in. Like if my password, which it's not, but if my password were A, B, C, D, E, if I typed it E, A, B, C, D, that wouldn't count. It wouldn't be accepted. So the order actually matters. That's an example of a permutation. And we have 1, 2, 3, 4, 5, 6, 7, 8 letters. 8, pick 5. Okay, or 8 permute 5. Lastly, we have 40 people purchase raffle tickets. 4 winning tickets are selected at random. If each prize is $500, and how many different ways can the prizes be awarded? So it doesn't matter if you're picked first or you're picked last, you get the same $500 prize. So this is an example of a combination because the order that the names are picked doesn't matter. So if Johnny, Becky, Sarah, and Anna all won, it's the same as if Sarah, Becky, Anna, and Johnny won. So the order doesn't matter. That is a combination. That would be 4 chosen from 40, or 40 choose 4. Remind you one more time that the general formula for n choose r is n factorial over n minus r factorial times r factorial. Okay, we're just going to remind ourselves of that because the next thing we're going to do is we are going to actually calculate combinations. Just a reminder before we begin, 0 factorial is equal to 1. You're going to see that that's very important in this situation. Remember our formula, n factorial over n minus r factorial times r factorial. So this first example, example A, I'm going to substitute the values into the formula. computing or calculating 5, choose 5. So in a set of 5 things, we're choosing 5 of them, and order doesn't matter. So following order of operations, we need to do that parentheses first. So 5 minus 5 is equal to 0. So that's 0 factorial. In the top, we have 5 factorial over 5 factorial here. 5 factorial divided by 5 factorial is just equal to 1. And 0 factorial is equal to 1. So we get 1 over 1. There's one way to do 5, choose 5. Because if the order doesn't matter and you're choosing all of the objects, then there's really one way to do it. So if I'm picking between the numbers, if I'm picking 5 numbers between the numbers 1, 2, 3, 4, and 5, and the order doesn't matter, if I have 2, 3, 4, 5, 1, that's the same thing as having 1, 2, 3, 4, 5. So there's only one way to have that combination. That's going to be true for any time I have in, choose in. That's just going to be equal to 1. Let's look at the second one and put in the values, and then we'll solve it together. Order of operations tells us that 5 minus 4 is what we're going to do first. So that's going to be 5 minus 4 factorial is 1 factorial. And then in the top, we have a 5 factorial, and then in the bottom, we have a 4 factorial. So if you think about it, 5 factorial is actually the same thing as 5 times 4 factorial, because that'd be 5 times 4 times 3 times 2 times 1, which is the same thing as 5 times 4 times 3 times 2 times 1. So then 4 factorial divided by 4 factorial is 1. 1 factorial is just 1. So we have 5 over 1. So the answer to this question is that there are 5 ways to have this happen. Okay, so 5, choose 4. The answer to that is 5. All right, let's do 5, choose 3. So we have 5 factorial over 5 minus 3 factorial times 3 factorial. We're going to do that same kind of manipulation of the numerator and the denominator. First, we're going to do the 5 minus 3, which is 2 factorial times 3 factorial in the denominator. And then in the top, the biggest factorial we have in the denominator is 3. So essentially, we're going to rewrite 5 factorial as 5 times 4 times 3 factorial. The reason why we do that is because then we save some time, so we don't have to write 3 times 2 times 1, 3 times over 3 times 2 times 1, and then have to cancel each one individually. We can do it all combined with the factorials with one another. So then we have 2 factorial, which is 2 times 1, which is just 2. So in the numerator, we have 5 times 4, and I'm doing this in red below. 5 times 4 over 2. Well, 2 and 4 can cancel. And so I'm left with 5 times 2, which is 10, or 10 over 1, which is still 10. All right, I'm going to follow suit and move downwards. And then we're going to do F, E, D. I'm going to just stop and show the work and show the answers. You can pause and try it yourself and then compare your answers. Okay, so once you calculated these on your own, I hope that you realize the pattern that you see happening. 5, choose 5 gives us one possibility. That's the same result that we get when we have 5, choose 0. If I have 5 numbers and I'm picking none of them, there's only one way to do that. I just don't pick any of them. Okay? If I have 5, choose 4, that's the same result as 5, choose 1. And then we have 5, choose 3 is the same thing as 5, choose 2. We get the same number of combinations. We're just going to go over 3 of these next examples. This might help us kind of get a handle on using the combination formula. Right here, we have an election ballot asks voters to select 4 city commissioners from a group of 7 candidates. And how many different ways can this be done? So here we go. We're asking for 4 city commissioners, from a group of 7 candidates. It doesn't matter which 4 they are, they're all getting the same position. And so we start with 7 and we're choosing 4. So using the combination formula, we end up having 7 factorial over 7 minus 4 factorial over 4 factorial. So we have 7 factorial over 3 factorial. We need to do our order of operations first, so we need to do that parentheses over 4 factorial. And then we can rewrite 7 factorial as 7 times 6 times 5 times 4 factorial, because our largest factorial in the denominator is a 4 factorial, and we'll see that that will cancel out. Those cancel, leaving us with 7 times 6 times 5 in the numerator over 3 times 2 times 1 in the denominator. Well, 3 times 2 is 6, and 6 times 1 is 6. So that's a 6 in the denominator, so those cancel out. So we're just left with our answer being 7 times 5, which is 35. Let's do the next one. A 5-person committee is to be elected from an organization's membership of 12 people. So 5 are being selected from 12 people, and they're just being, it's a 5-person committee. Everyone's got the same position. Order doesn't matter. It doesn't matter if they pick person A, B, C, D, and F. I skipped E. So A, B, C, D, and F. But then they select F, A, B, C, D. That's the same group of people. So the order doesn't matter for this one. That's a combination. How many different ways can this be done? Well, we're starting with a group of 12. We're choosing 5. So we have 12 factorial over 12 minus 5 factorial times 5 factorial in the denominator. And now I'm going to do the parentheses first. So we have 12 factorial on the top over 7 factorial times 5 factorial. So that's going to be 12 times 11 times 10 times 9 times 8 times 7 factorial. Remember, we're going to stop writing all the numbers down once we get to the number that matches the highest one in the denominator. 7 factorial times 5 factorial in the denominator. The 7 factorials cancel, leaving me with 12 times 11 times 10 times 9 times 8 in the numerator. 5 factorial. And I'm going to play a little bit of a number sense game. This is helpful if you're really good with numbers and you know your multiplication facts. Well, 5 factorial is actually equal to 120. And 12 times 10 is equal to 120. So we have 120 times what's remaining, 11 times 9 times 8. And so the 120s would cancel. So my answer is just going to be 11 times 9 times 8 is 792. There are 792 ways to pick that 5-person committee from the 12, or to choose the 5-person committee from the membership of 12 people. Now, if the order mattered, there'd be so many more ways to do that. But because everyone's on the same level, there's no differentiation between what position they're selected in. There's only 792. That's still a lot of possibilities, but there's only 792. Okay, and then the last example we're going to look at is going to be this number 9. Of 11 possible books, you plan to take 3 with you on vacation. How many different collections of 3 books can you take? Well, that's going to be, out of 11, we're choosing 3. So using our formula, we have 11 factorial over 11 minus 3 factorial times 3 factorial. Well, 11 minus 3 we do first, following order of operations. So that's going to be 8 factorial times 3 factorial in the denominator and 11 factorial in the top. But I can rewrite 11 factorial as 11 times 10 times 9 times 8 factorial. So then our 8 factorials will cancel. And then we have, this one doesn't have as nice of a little cut down, simplify number sense action to it. But we end up getting 3 factorial is equal to 6. And 11 times 10 times 9. Well, 11 times 9 is 99. 99 times 10 is 990. And then we can divide 990 divided by 6, which equals 165 ways to pick our books. Hopefully this gave you enough practice examples of using combinations. If you have any questions, please feel free to email me. Thank you so much.